to a new edition of the Heat Treat podcast. Today we have my great friend Mike Coburn from AFC Holcroft, and we're going to talk about salt quench hardening. Salt as a quenching media, the special considerations to have with salt. What do you need to take in consideration when we're using salt? Mesh belts, IQ furnaces, salt baths, the benefits of salts, the pros and cons. And Mike is, I believe you're in Michigan right now. And I just would like to say how I miss the days that we actually work together, visit customers. And Mike is a great lover of steak and tequila, and we actually miss
Yes,
those days. So, how are you, Mike?
I'm doing great, Carlos. The topic of steaks and tequila reminds me of a couple things. First of all, the first time you introduced me to the Mexican flag, I thought
Right.
that the red and the green were kind of weak, and you said that's because there's no tequila in them.
Just,
So
just,
from that
just,
point,
just explain to the audience the Mexican flag on drinks. It's a shot of lime, a shot of tequila, and a shot like of tomato juice. So it's green, the lime, white the tequila, and red the oyster juice. That's a tequila flag.
so after I found that out, of course, I just wanted the tequila portion.
Yes, I actually took the other one, but we could
Yeah,
actually have a full podcast on tequila and steak with you, right? But today
yeah,
we're
we could do that.
today we're gonna focus on salt quenching, which is not that interesting,
Yes.
but some people find it passionate. So,
Hmm.
Mike, I believe you have a bunch of expertise on this topic, but why don't you, make an introduction and tell the audience how you got this experience, please?
All right. Yeah, thank you, Carlos. So, a long time ago in a galaxy far, far away, I started off working in a salt bath commercial heat treating operation, sweeping floors, loading furnaces, uh, moved into learning how to straighten high-speed steel broach cutting tools, learned how to harden them. And eventually, with the completion of my college degree, I started running that business. And then I ended up buying the business from the old man that owned it prior to me. We had a good run for quite a few years, and then the economy changed um, as some of my tool and die mom and pop customers were actually closing down because business was going to China. It got to a point where I couldn't keep the heat treat operating, so I shut it down and went into selling capital equipment, which eventually led me to working for AFC Holcroft, where I'm selling capital equipment for heat treating purposes. And because AFC Holcroft has a major line of salt related pieces of equipment, the UBQA, the MBA furnace, it's just been a natural progression in my study of salt, the use of that knowledge.
That's fantastic. So, a bunch of people does use oil as a quench medium. A bunch of salt was used in the past, uh, but now it seems like salt is getting back on motion, and it's becoming like the trending process nowadays. But can we have a brief introduction to salt as a quenching media, the salt quenching hardening process, if you want to call it obtempering or martempering or how you want to have it. So, and then let's go into benefits, pros and cons of salt, the special considerations you have to have. Of course, distortion is a big deal on the equation of salt. But let's start with salt 101. What can you tell us as salt as a quenching medium?
All right. Well, let's touch base real quick on the truth that you mentioned in salt kind of went away and it now seems to be coming back. A lot of people don't understand how varied salt is. The salts that were really bad were the old cyanide salts. There were barium cyanides, different chloride cyanides. They were used for carbonitrating, carburizing. They were very dangerous and they went away. Oil's always been around, but it does have certain limitations. And we'll get into that a little bit more. But various types of salts, there's salt can be broken down into three groups. You got low temperature salts, and those are nitrate based salts. And typically their operating range is anywhere from 300 degrees Fahrenheit to 1150 Fahrenheit. And if you don't mind, I'm going to stick with using Fahrenheit rather
That's
than
fine. That's
Celsius.
fine. That's fine.
There are medium temperature salts, which are your chloride salts. Their operating range is approximately 1200 to 1800 degrees Fahrenheit. And then you have high temperature salts, the barium based salts. Their operating temperature is about 1800 degrees Fahrenheit to 2400 degrees. For our purposes and the rest of this conversation, we're primarily going to focus on the nitrate based salts,
which is low
because
temperature salts.
the low temperature salts, because that's what you're going to find companies using for neutral hardening, tempering, mark quenching, whatnot. So going from there, if we want to just compare, just in a very basic level, the operating range with salt versus oil and the flexibility that salt offers. With salt, you've got a salt that can operate anywhere from a temperature of say 350 to 1100. All right. Most tempering occurs between the temperatures of 450F, 500F, and 750F. Oil does not get that hot before it hits its flash point, right? So you have different opportunities that you can run with using the same quench medium in your tank, that same salt. You can operate it at 325, you can operate at 340, or you can go up to 750. So you can do various types of mark quenching or tempering
So salt
in
is very
that
flexible
solitary
temperature
quench bath.
wise.
Exactly. Yeah. Much more versatile, I
Okay.
think, than oil. It's not that oil doesn't have its place in the industry. It's very popular.
Mm-hmm.
It's probably one of the most popular quenchants, but there are limitations.
Mm-hmm. Well, what else do we have to know about salts? I mean, it's one of the big thing is distortion. Most of the people which are getting distortion with oil, they want to explore quenching with salt because it's because of the thermal shock. But is this only that, or it has to have? There's a couple of other factors like the film, that the bubbling film, or the way we actually agitate salts. What can you tell us regarding how salts is different from oil?
Yeah. Okay. So with oil or with water or brine, you basically have three phases. You have a vapor phase, you have a boiling phase, and then you have a convection phase. During that initial vapor phase, um, parts do not get consistent cooling or heat extraction. And that in itself can set up stresses, especially with complicated parts. With salt, there is no phase, there's no vapor phase. It is a single phase quenchant, and the nature of salt, um, it's extracting heat not only by conduction, but by convection as well. So it extracts heat much more uniformly. And by eliminating some of these stresses, the phase transformation stress, the just the stress of different thicknesses of the part, cooling slower than thinner sections of the part, like a gear tooth, you get a much more uniform quench and therefore less distortion. Salt also adds buoyancy to the quench. So what'll happen is the part is almost suspended in the salt in a way that it wouldn't be from, I'm sorry, from being hung in like oil or water.
Now, what are the special considerations we have with salt? We've seen that the salt has to be constantly agitated, and it has to be on a certain temperature. Otherwise, they will solidify. Some of the equipments, they have like a holding tank in order to maintain the main tank. What's to know there? And also, salt has to be constantly checked, right? Their chemistry in order to add more salt or to fill it with more water, so we can actually have the same results that we needed. What are the special considerations we have to have with salt quenching with that?
Special considerations.
In comparison with
Well,
oil.
yeah, well, the first thing with the salt quenching is you need to know what the lowest operating temperature you want to work with. because depending on the chemistry of the salt, you can come up with a operating temperature range as low as 325. That salt will have a melting point of 275, 285. You always want to keep a little bit of a higher temperature operating range than your melting point. So let's say your salt's melting at 275 and you think your lowest temperature for operation is going to be 325 or higher, right? You're fine. What happens if you want to take that salt temperature down to, say, the 300-degree Fahrenheit level? The salt begins to thicken up. It gets muddy like, and it doesn't do as good a job extracting the heat from the part. And there's a lot more drag out that goes from the quench out of with the part. So considering what temperature ranges you want to work will dictate what kind of salt you want to work with. After that, salt is actually pretty maintenance free. Yeah, you want to check its chemistry once in a while, but most people that are operating with oil, they have to check their oil on a regular basis to make sure it's still working up to snuff, right?
So same stuff,
Uh,
right?
yeah. So with an oil quench operation, you're running the oil from your quench tank through a heat exchanger, right, to keep it at a certain temperature. All right. Well, with salt, we have heating tubes, immersion tubes that heat the salt up. But then as parts are flowing into it from the austentizing furnace, it'll stay hot. So then what we do is kind of like oil, we keep it cool. And we've got some unique systems where it allows us to keep that salt at a temperature.
Now, let's talk about the conception that when we are thinking about salt, we're thinking about parts that can go on mesh belts or very big parts. Is there something in the middle? Because when you do fasteners or components that can be heat treated and quenched on mesh belts, they are very different from the ones that we actually use on IQ or other applications, which are very big parts to be austempered. So, what's the right conception or the misconception in there? Is there something in the middle, or it's something that is very fastener like, or or are those the other very big casting parts?
Well, we typically, when we look at like fasteners, when we look at metal hose clamps, clips, and stuff like that, we're thinking of small parts with small diameters. And ideally, they can be run really well on a mesh belt furnace that drops them into a salt quench. And that salt quench tank may or may not have an agitator in there. Okay. The parts settle down through the salt onto a belt that then conveys them up and out, and they drop into a wash tank. And in some cases, they come out of the wash tank and they drop into a rinse tank. For the larger diameter parts, that's where we would recommend our IQ furnaces, which we call UBQAs, Universal Batch Quench Temper. And these are integral salt quenches that are all enclosed, and we can do things in addition with these furnaces that we don't typically do with the mesh belt furnace, and that is adding water. So, how do you increase the severity of your quench tank or your quench system? You can do it by altering the temperature of the salt. You can do it by adding agitation, and you can do it by the addition of water. With the system of a mesh belt going into a quench tank, the best way to add water would be, and we don't do this that I know of, but would be to put a spray or a mist on the surface of the salt. Okay. With our UBQA systems, what we actually do is we trickle water down through the agitation peller, and in the vortex that's created by the agitation, that's where the water disperses. And we can usually add about, depending on the temperature of the salt, we can usually add about 2 to 3% water, which dramatically increases the quench severity. And that quench severity is what allows the larger diameter parts to hit their hardness, whether we're going for a bayonetic structure or a martensitic structure. It's that quench severity that gets us to the rock well we're looking for.
And there's also the belief or the conception that when you're using water or salt, you need to have like something a little more higher than regular steel grades. We're talking about stainless steels because salt is corrosive, it's not treated accordingly to standards. What can you tell us about how salt will begin to corrode the vessel or corrode the tank or get sticky in some of the parts that are on the shell of the furnace if not worked correctly?
Well, working with the typically the salts that we're talking about when we're talking about tempering and mark quenching in our types of furnaces, we're talking about sodium nitrite and potassium nitrate salts, and they're usually in a 50-50 blend. And in that, they're not that corrosive. We can use mild steel tanks, we can use stainless steel tanks. That really depends on what the
Budget on
customer
budget.
wants. Yeah, what the customer wants to spend. I will tell you this, one thing that would help is regular maintenance. Even the salt quench tank should be stopped once in a while. Transfer the salt out of the quench to a salt holding tank where you can keep it warm, keep it molten, and then pull out the conveyor and sludge the furnace. Because I can tell you from my own experience, what happens is when enough sludge collects on the bottom, it actually gets hotter and it sits there. And that's where you can run into some corrosion problems. So, cleaning the tank and maintenance, uh,
it,
that,
it,
that
it's,
shouldn't be that shouldn't be their primary concern. Is the tank
it's
corroding?
really to have a preventive maintenance program, and it's relatively easy if done periodically, right?
Yes.
Easier said than done to heat treaters, but that's the theory, right? Now,
The theory.
let's talk to the washing or post washing of the parts, right? Because like oil has to be washed because it has a lot of remains, and oil on the tempering process, can burn and create a lot of fumes. How is the salt behavior after quenching? Is there a lot of salt remains on the parts? Do they drain? Do they require a specific type of washing, rinse or dunk? And when we do our tempering, we don't need, I believe it was on our tempering, we do not need a tempering process, but we do need one when we do neutral hardening or so. How is the behavior after we have quenched the parts, after austenizing, quenching, the following process? How do we treat the salt? How do we wash it away?
Well, that's a good question. So, most of the washers for oil quench parts have some detergent in them. Salt washes away just with good hot water. Uh, in some cases, I know customers actually will put a rust preventative in their second rinse tank. Uh, but the water that they're washing with, first of all, the amount one of your points was the amount of salt drag out. That all depends on
Yeah.
the temperature of the salt and the configuration of the part. The hotter the salt, the more viscosity it has, and the more it's going to run off, just like water. Uh, a part like a hose clamp in your car versus any type of part that's cupped, like bearing components and whatnot, uh, they're going to drag out less salt than the part that has some type of blind hole. Okay, but when you look at the salt building up in your wash tank, and ideally we like to have about 2 to 3% salt in that wash tank, but when it gets up to about 12%, and you use a salt refractometer with a rating of 0 to 28%, and you just to check a sample of your wash water. When it gets to be about 12%, we recommend reclaiming the salt. Now, some heat treaters don't want to do this. And in most municipalities, not all maybe, but most municipalities, that salt water from the wash tank can be washed down the drain into the sewer system. The sodium nitrate and the potassium nitrate, they're food preservators. They're they're fertilizers. So there's nothing really harmful there. However, some other heat treaters will look at it, well, if I'm just washing that used salt down the drain, that's a waste because now I got to buy more salt to replenish the quench tank. So
Mhm.
by reclaiming the salt, you're, and we have systems where we take the wash water, put it into a holding tank, then we run it through an evaporative process where we boil off the water, which we then recondense into a water holding tank while the molten salt slowly dries and settles down through the system into a tray that resembles a large ice cube tray on rollers. So now what the heat treater is doing is they're not only recycling the salt, but they're reusing the water. Okay. So it's a very green environment.
Process.
Yeah, it's a very green process. And that is in contrast with an oil quench operation. All right.
And price wise, is there a study or do you have an idea how much investment of capital will take to fill IQ quench tank for oil against quench tank for salt? I mean, if we could actually put it in a perspective, well, what's the cost if it's 1 to 1, 2 to 1? Do you have some of that data?
We don't have that data, but I can tell you this. Uh, you fill up your salt quench tank and you're gonna add salt back to it periodically from the salt that you may be reclaiming or adding new bags of salt or adding from the barrel. Uh, your oil doesn't last forever. There comes a point where you do have to
Totally.
replenish the oil. So, and I think Chip Keogh may have said it on his podcast with you that his old company probably had some uh, UBQA furnaces still operating with the original salt in them.
He said that.
So, yeah. So I don't have a commercial number on the comparison between starting a tank with salt versus starting it with oil, but I
The
think
thing is
I
that you can
think
recycle
oh,
salt. I mean, I believe the point is
yeah,
that salt can be recycled. It's treated correctly,
yeah,
right?
and obviously with oil, and I'm not against oil, but
No, I
there are
mean,
pros and cons to both of them.
there's a place for each process on the industry. I mean,
That's right.
today we're just considered the salad quenching process. I mean,
Yeah,
it's
yeah,
not good or evil.
yeah. Of course, when you're dealing with oil, you do have some disposal issues. So there's a much bigger picture, I guess, that the heat treater has to weigh in considering whether they're going to go one way or the other.
Specifically, the specs. When me being a commercial heat treater as well, I mean, we got IQs and we got oil IQs, right? And from time to time, we will get specifications for salt quenching, right? This part has to be salt quenched, right? This is a temporary part, right? And what the first thing the guys want to do is they wanna see if our oil is flexible enough, right, to hit that temperature and try to convince the customer to run some trials, yeah, just not to invest on other capital equipment that we do not have if the volume are not big enough. So that's what we're trying to do, right? But filling the existing capacity. But each process is spec. This is uh, oil quench, this is salt quench, or this is temper, this type of material. And based on that, just specify where to treat it. But heat treatment has a bunch of versatile ways to get to the same specification. But if the spec calls a process itself, it's very hard for you to convince the customer or the OEM to switch process, if even if you could actually get to the same results. Have you had that situation?
Yeah, that's a good point. That's true. I can tell you this, that back in my heat treating days, I had a handful of customers, I'd make the sales call on them and I'd go, hey, I know you got more work than this. Can't you send me a little bit more work? What do I need to do to get a little bit larger share of your work? And it came down to this. They were doing a lot of work for aircraft aerospace,
Mm-hmm.
and the heat treat was specified as vacuum treating.
Back in treating.
But but you know what? You don't run a vacuum furnace economically without putting a full load in it. And there were times where these customers would have a rush, that there'd be an emergency, and they had to deliver a dozen parts in a rush, and they'd come to me because I'd turn those parts around in 24 hours, just run them through my salt bath furnaces. I'd preheat them, high heat them, austenize them, quench them. I'd wash them, I'd temper them, I'd temper them, and then I'd wash them again, and I'd grit blast them, check the Rockwell, and I'd deliver them. Uh, they didn't have the same look as parts treated in a vacuum furnace. The parts coming out of a vacuum furnace had a really shiny silver look, whereas mine had kind of a dull gray part. But I got them their parts back in no time at all.
And
But
under hardened spec.
and yeah, they were as hard as it needed to be. I think for the most part, those were like 62 to 64 Rockwell on the C scale specification, and they were generally a high speed steel, like an M2, maybe an M4 type steel. But the customer's ultimate spec was for vacuum heat treating. So I couldn't get the bulk of their work because I was simply salt bath, but they'd use me in an emergency.
Right, because there's a bunch of ways to get the same result, but if a process is specified, sometimes the customer say, "Can you do this process or not?" Like I can get to the results by doing a different process with the capacity
Yeah.
that I have, but it's very hard to get approvals if you're aerospace or automotive. But sometimes customers they can look away and they go like, "Well, this kind of an emergency, and we'll make things happen." But that's it's about just selling your capacity, I guess, right? And like you're saying, hey, what do I need to do to get a larger share of your work? Will be to validate your process, and it should be faster, better, and economically it should have an advantage, right? And I believe that's what the salt it's trending right now. That it has it's more flexible, it's green, as you're saying, and I believe
Mhm.
there's some recyclable, of course, and it should have a price impact on distortion and things like that. So, what are we missing about the process? Can you, tempering wise, we didn't. We spoke about the washing system, but we burn a bunch of drag water salts when we're doing tempering, or that doesn't happen on when we do salt quenching. Like oil, when
Well,
we actually temper oil, drag oil, we have a bunch of fumes.
yes.
What can you tell us about fumes? How do they behave on this process?
Well, when you're quenching into salt, you don't have a flash point. You don't have the potential for flame or fire, and you really don't have any fumes. Uh, Depending on what process you're doing, if you're going for a bayonetic structure, as you had suggested earlier, you don't need to temper. You come out of the wash, you go into the rinse, you dry off, and you're done. You move along. Uh, we can also quench parts coming out of an oxidizing furnace for martensite. And in that case, they go through a wash, they go through a rinse, and then they go through a tempering process. You know, when we talk about salt bath hardening, salt bath quenching, and we talk about some of the various pieces of equipment that make up one of these facilities, you know, we have an oxidizing furnace, we have a quenching system, we have a wash and rinse system, we have a salt holding tank. These are atmosphere furnaces, so we have a endo gas generator, just like an operation that's quenching oil would have. Uh, a lot of times with batch equipment, we actually have temper furnaces, but we're using them as preheats prior
Right.
to going into the oxidizing furnace. Uh, but there's nothing to be said for this heat treater that says, yeah, most of my work is for bainite. I use my tempers as a preheat. But the salt that he has in his tank will operate at a range that would allow him to mar quench. And so he can pull those parts out if they've been mar quenched, wash them, rinse them, and pop them into the temper for a temper cycle. So the heat treat facility, whether it's a mesh belt tempering line or a UBQA line, contains all the basic ancillary equipment so that the the heat treat operator can offer more than just os tempering. They can do neutral hardening. They can do mar quenching. So very versatile.
Now let's talk another misconception on salts. Is like uh, when we're using the salt process or to do quenching on salts, and we have a tray or a fixture, it's gonna destroy it relatively faster than if we're using other quenching mediums that are that not aggressive. Do you have an opinion on that?
Well, your fixtures, they're going through a thermal shock every time they're being heated up and quenched out. I would tell you that it's, at least for os tempering, it's probably less drastic than it is for an oil quench, and that's because of the temperature range. You can look at like a TTT chart on a particular steel, and you obviously want to dive down fast enough to avoid that pearlite nose. All right, but in a lot of cases with us tempering, you're stopping. You're going into salt at a temperature that's usually 25 to 50 degrees above the martensite start level, and then you're holding for a period of time to allow that complete transformation from austenite to bainite. With mark tempering or mark quenching, you can do the same thing. You can drop to a point that's just above the martensite start point, hold briefly just to allow the part's entire surface and inner portion to stabilize in temperature, and then you can drop down to the martensite start and go out to the martensite finish, and then air cool. So
The thermal shock.
yeah, the thermal shock of it. Your fixtures, it really depends on the cycles you're running. You
Hmm.
know, typically, most oil quench operations, the oil is at 150 degrees, right? 180 maybe. There are applications where they use a 250-degree oil or even a 350-degree oil, which, by the way, are temperatures that are just too low for converting to bainite. But that just is much more of a thermal shock. So I can tell you from my experience as a commercial heat treater, my fixtures, they didn't get banged up too badly, but I wasn't dealing with that drastic change going from an oxidizing furnace at 1650, 1700 degrees down to 150 degrees in oil.
So yeah, it's all about thermal shock. So Mike, it's
Yeah.
been great talking to you about salt quenching. You're a real expert on the subject, and you actually live it yourself. Is there something that we actually missed regarding this process that will be worth telling to the audience?
I think we've covered a lot of it. Some of the things to watch out with salt that
Yeah, good. Yeah,
may
good things. Yeah, things to consider. Right.
yeah. Some of the things that may have given salt a black eye in the old days, obviously the cyanide salts had a lot to do with that. Parts with blind holes need special consideration in being washed. Otherwise, you don't get all the salt cleaned out of a blind hole. That is an issue you don't have with oil, right? But that's not insurmountable. It's all about, you know, good maintenance and house cleaning.
Good mention, Haskell. Thank you so much, Mike. Mike, it's been a blast talking to you about quenching. You're a great friend. I look forward to the
Likewise.
next time we actually meet in person. I have that steak and that glass of tequila. It can be at the States, it can be here, it can be Europe, you name it. But it's thanks for your time and sharing with you, with the audience, with me, your expertise on the subject. I just would like to remind the audience that we're uploading weekly podcasts on heat treat topics by experts like Mike Coburn, right? We're LinkedIn, Spotify, YouTube, and we'll see you next week with another expert on heat treat on the Heat Treat podcast.